Hi everyone, this is Miss Park, your favorite chemistry teacher. In this video, I'm going to go over Thursday's asynchronous assignment for October 22nd. And in this video, I will try to teach you how to use the PhET simulation and go through some of the questions that are at the end of your assignment. So let's take a look. So you should have your asynchronous assignment opened up for Thursday, right here. So the first part is some practice problems with isotope names, looking at the number of mass, number of protons, and number of neutrons. So for this, I suggest that you look at the slides we reviewed on Wednesday. Right, so the focus of this video is actually the latter part of your assignment, using the PhET simulation to complete these problems on the second page. So I'm going to click here because it says to click here to get to the PhET simulation. Once you get there, we have Isotopes and Atomic Mass PhET simulation. You're going to click play. And between the two, you're going to actually click on mixtures. And that's what I instruct on here as well on your assignment. So once you get here, you're going to see the screen and you're going to click on Nature's Mix. All right. And this is what I want you guys to be seeing on your screen. And the next thing I ask you to do is to click on LI on the periodic table on top of the simulation. So I'm going to click on LI. And you're going to see this black screen with a bunch of dots that are green and purple. And you're also going to see some information on the right side of your simulation. So what this is, so we talked about isotopes on Wednesday, right? We talked about how isotopes are different versions of the same element. And they're different because of the number of neutrons they have, right? So because the number of neutrons are different for isotopes, their masses are also different. So in this example here, we have lithium, the element lithium, and lithium has two isotopes. And you can see that in the black screen or black box, that there are way more lithium-7 isotopes than lithium-6, right? You see the purple dots and the green dots in the screen. So this is just a representation of what abundance in nature means. So we talked about abundance, right? Abundant meaning like a lot of. So we would say, when we look at this, we would say that lithium-7 is more abundant in nature than lithium-6, right? Because there's just more of these green dots here. And you can also see the percent composition. I wish this would say abundance, because that's the word that we've been using, right? We can see that lithium-7 is 92.41% and lithium-6 is 7.59%. So this is the percentage that lithiums make up in nature. And here on the bottom, we have average atomic mass. And we can confirm this number on the periodic table. So I'm going to go to the periodic table here. If I look for lithium, where is it? Right here. We see that the average atomic mass is 6.94. And here it is, 6.94. So what this tells us is that the average atomic mass is closer to lithium-7 because lithium-7 is just closer to the, no, what I mean is that lithium-7, because it's more abundant in nature, it makes sense that the average atomic mass would be closer to lithium-7, right? So that's what I'm trying to explain in this section, right? Everything that I just went over with the simulation is here. So let's actually do one element together so that you guys are all set for the rest of this assignment. So here we're gonna look at nitrogen, N, on the periodic table in the simulation. So I'm gonna go back to the simulation and click on N. And when I do that, I see these purple dots and the green dots. So we can clearly tell that nitrogen 14 is way more abundant than nitrogen 15, right? So that's the first thing I noticed. But I'm gonna go back to our assignment and actually see what my number 1 is. So it asks, what are the isotopes of nitrogen? It says name them. Okay, so let's go back to the simulation. So there are two isotopes, right, of nitrogen. We have nitrogen 14 and nitrogen 15. So I'm gonna go back and write that down. So nitrogen 14, nitrogen 15. Second question asks, which isotope is most abundant, and give the percentage. So I'm gonna go back to the simulation, and we see, you can see it in the black box, or you can even see it with the percent composition, right? And we see that nitrogen 14 is at 99.63%. So nitrogen 14 is much more abundant than nitrogen 15. I'm gonna go and write that down. So which isotope is most abundant? So it is nitrogen 14, and the percentage was 99.636%. And the next question is, what is the average atomic mass and which isotope is it closest to? So what is the average atomic mass of nitrogen? And here it tells us it's 14.0067, right? And I can confirm that from the periodic table, right? It's 14.007. It's just rounded on the periodic table. So I'm gonna write this down. 14.0067. You can put the unit AMU. We didn't really talk about this unit, but you don't have to write it because we didn't really go over that yet. And it asks, which isotope is it closest to? And this simulation is nice because it actually tells you, it has a number line to tell you that the average atomic mass is closer to nitrogen 14. And it makes sense because the average is just, it's almost 14, right? It is nowhere closer to 15. And that's because we know that in nature, there's just more nitrogen 14 than nitrogen 15, right? It's more abundant in nature. So when you average these two, you're gonna have an average atomic mass that's closer to nitrogen 14. Okay, so we're gonna write that down. Nitrogen 14. Yeah, you can just write nitrogen 14, right? So I want you guys to try and complete the next set of questions. Right, you're gonna look at magnesium and chlorine on the simulation. And then the last section is not using the simulation, you're going to answer these two questions. All right. Well, then I hope you guys finish the work and submit it on time. And if you have any further questions, you can always text me or email me. Thanks. I'll see you guys later.